Hello, this is Mr. Muller for lesson 1-5, square roots and real numbers. Alright, so this is probably going to be one of the more difficult lessons we've done so far. Not because it's hard, but because of all the things that you have to remember. First part is going to be evaluate expressions with square roots, and the other part is going to be to classify numbers. This is going to be the tough part. So lots of vocab to go over. Okay, so square root and perfect squares are the ones that we probably already know. But the things that get confusing are, the difference between a real or natural or a whole or an integer. So some of those things could be a little confusing. So let's talk about square roots first. So square roots is a number that is multiplied by itself to form a product. So that's the important part, that it's multiplied by itself. Okay, not by 2 or not by 4. It has to be the same number multiplied by itself. Okay, and the symbol, most of you probably recognize as kind of like a check mark with the line continuing. So that was what the square root symbol looks like. Oops, wrong way. Alright, so like here, since 4 times 4 is 16, so the same number itself is 16, that means the square root of 16 is going to be 4. And you see how they kind of have this 4 squared here? So square roots and squares are kind of the same, are kind of opposites. Okay, same thing with a -4 and a -4. Still going to give you a positive 16. So then when you see this negative sign out in front, you're just going to say the negative square root, or the square root of a -16 is 4. Important that the square root is out in front. Okay, and these are all of our perfect squares. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100. So 10 times 10, 9 times 9, 8 times 8, 7 times 7, and so on. Just all the numbers that are multiplied by itself. What do you get when you multiply them? Those are our perfect squares. Okay, important that when it's like this, where there's a negative sign underneath, that this is not possible, because there's no way that I'm going to multiply the same number times itself and get a negative answer. Remember how we talked about 2 negatives equal a positive? So if you ever have a problem where that square root, or where the negative sign is under the square root sign like that, that is not possible. No 2 numbers that are the same can be multiplied to give you a negative number. Okay? If you ever have something that you don't know, like the square root of 15, it's going to be close to 4 because the square root of 16 is 4. But if it's ever something like this where it's not a perfect square, you're going to type it in the calculator. Calculator is going to give you some big, long decimal. Knowing those, since you know all of these, since you know all of these, any number that's not one of those is going to be a huge decimal, huge irrational number. Okay, so kind of reviewing these, so square root of 16 we talked about was 4. Let's skip that fraction one for a second. Okay, let's forget it. So remember, since that negative sign's out in front, my answer is just going to be negative. Square root of 9 is 3. 3 times 3 is 9. Forget about that that negative sign for a second. Oh no, I have 25. Square root of 25 is 5. Okay, and now with the fraction, looks a lot more complicated than this, but you're really just going to break it up. Square root of 25, we just did, was 5, and the square root of 81 is 9. So that means the square root of 25 over 81 is 5 over 9. Okay, no trick to it, just take one each individually to figure out what it is. Alright, real numbers. Okay, so it could get kind of confusing with all the different kinds of numbers. So real numbers are numbers that can be represented on a number line and can be classified according to the characteristics. Okay, so basically every number is going to be a real number. Real numbers are pretty much anything. Natural numbers are the counting numbers. So if you have a little brother or a little cousin and you ask them to count, well, they're probably not going to start with 0, or they're probably not going to count negatives. They're going to probably start at 1. So natural numbers are the counting numbers. Whole numbers are pretty much all the natural numbers, but then they throw in 0. So whole numbers and natural numbers are pretty much the same thing except for zeros. Integers are all the positive whole numbers, and then they include the negative whole numbers as well. Okay? Rational numbers are pretty much numbers where you know all the digits too. So even if it's a big, long decimal, like 1/3 is 0.33333, well, if I ask somebody what 1/3 was, they're going to be able to say 0.33333, and they're going to know all the digits. So that's a rational number. 9/10 is 0.9. Okay, then you're done. 7/1 is 7. 1/2 is half, so 0.5. Okay, as long as you know all the digits, it is a rational number. Okay, terminating decimals kind of goes with rational numbers. So numbers that you know all the digits to. So like, 1/2 is 0.5, 2.75, 4.0. They are terminating. Okay, repeating decimals we talked about too with the 1/3 is 0.33333. It's a repeating decimal. Anytime you have that, repeating when you type it into a calculator. Irrational numbers are the ones that we don't know all the digits to. So like pi. Nobody knows all the digits to pi. It keeps going on forever and ever. Same thing if you're doing square root of 2 or square root of 11. Any of those square root of those not perfect numbers are going to be irrational numbers. Alright, so if I'm looking at this, I have negative 32. Okay, so negative 32 is not going to be a natural number. It's not going to be a whole number. Okay, but it will be an integer. Okay, integer should be one of those. There it is. Okay, integer. It will also be a rational number because we can write it as a fraction, negative 32 over 1. It's a rational number. And then it would also be a terminating decimal because it doesn't go on forever. It's not like negative 32.174512. Okay, it's not going to be going on forever. We know it is terminating. Okay, 5. Well, it's pretty much going to be all these. It's going to be a natural number. If you're asking somebody to count, they're going to say 5. It's going to be a whole number. It's going to be an integer. It's going to be rational. So all of those would count as 5. Okay. Let's see if I left anything off. So it's going to be rational. It's going to be an integer. It's going to be a whole number. Going to be a natural number. And then it's also going to have that terminating decimal. Okay. All the digits in 5 are 5. That's it. There's nothing else there. Okay. And then some more examples here. So 7 4/9. Okay, so it's a rational number. And then it's also a repeating decimal because if you type in 4/9 in your calculator, you're going to get 0.444444444. Keep going forever. Okay, negative 12 is a rational number, a terminating decimal, and an integer. Okay, you can write negative 12 as a fraction, negative 12 over 1. There it is. It's a terminating decimal. I know all the digits. The digits are negative 1, 2. Okay, and it's also an integer because remember, integer counts those negative numbers as well. Okay, and then square root of 10, well, it's not going to be a nice number like, 1, 2, or 3. It's going to give us this big long decimal. So that is going to be an irrational number then.